Good evening to one and all. Myself, Dr. J. Namrata Manohar, is back with the fourth episode on tips to master computer programming. In my first episode, I had presented 46 queries or questions, the answers to which you should obtain and understand to lay a strong foundation for your programming skills and expertise programming. In episode 2, I had presented the preliminary terms of computer programming. In episode 3, I had presented answers to the first 20 questions as applied to C programming language. Hope by now you have set yourself into the programming environment. Let us now continue to progress with this fourth episode, in which we shall study the answers to questions 21 to 30 as related to C programming language. Before we begin, I would like to inform about the 8 videos I have made public so far, spread over 3 aspects. One is computer programming, second is embedded systems, and the third on making research thrilling. These episodes would serve to be a background for the present episode and also give you a right direction towards all-round development. The 8 episodes are Importance of Programming for Electrical Engineers, Computer Programming for Beginners, Fundamental Terms of Computer Programming, Make Research Thrilling, Preliminary Introduction to C Programming Language, Embedded Systems Learning Strategic Approach, Episode 1, Reading and Writing Skills to Excel in Life, Profession and Research, Embedded Systems Programming Strategic Approach. I request you to subscribe to my channel so you will be able to study the previous episodes. Now, if you are a student, you may keep a notebook in a dictionary level so you can prepare your notes well. Now, let us begin this episode 3.1, Tips to Master Computer Programming, Application of Queries 21 to 30 of Episode 1 to C language with program examples. The episode also presents program design and development, operation research approach stages, and a few interview questions. Commencing the answers to the questions in progress, question 21 is, what is the character set supported by the language? Now, since we are discussing about C programming language, the character set supported by C programming language has 256 characters. Each character has its own ASCII value. Now, what is the characters in the C programming language? They are alphabets, both upper A to Z and lower A to Z, digits, numerals 0 to 9, and special characters plus, minus, multiplication or star, forward slash, percentage, or we use for modulo, less than, greater than sign, equal to, tilde, ampersand, not, dollar, hash, caret, ampersand. This is at the rate, this is at the rate, and this is ampersand, underscore, vertical line, backslash, semicolon, colon, single quote, double quote, comma, dot, question mark, braces, parenthesis, square brackets, and flower brackets. So these are the various special characters we can use. White spaces they include spaces, tabs, new lines, and form fields. We will be seeing these in the subsequent examples. Escape sequences. Special meaning characters are prefixed with a backslash, such as /n. /n means new line. Suppose you want to print a message in a new line, then you can. We will see during our examples. /t for one tab, double slash for blacks for a character, slash colon, that is single quote, and slash double quote. So we will see during our examples how to apply them. Now, question number 22. This is I have split into what are the various data types in the C programming language. Primary data type and derived data type and user-defined data type. C is a very strong language because it is supporting derived data types are limited. But during our data collection and processing of large amount of data, we may want to, and for effective use of memory also, we need some specific support. So here we have the primary data type, a void, that is null, it does not return any value, integral, floating point. Coming to integral, it is of two types, integer and character. Now integer we have signed int and unsigned int. In signed int we have int, short int, long int. Unsigned we have unsigned int, unsigned short int, unsigned long int. All these we have seen the explanation in the previous episodes. Character we have char, signed char and unsigned char. Signed means they will take positive and negative values. Unsigned means they will take only positive values. Now coming to the derived data type, we have array, we have functions, and we have pointers. User-defined data types are structures, union, enum. All these applications, some examples of these we will see in this episode, and how to make use of this in our real-life applications of array, function, pointer, structures, union, enum, we will see in our subsequent episodes. Now, coming to 22b, that is, here we will see what is the size of each data type. Why the size? Size means number of bytes. That is, how much byte each data type will occupy. This is important because we need to know how to manage the memory. We should not waste memory. So, for effective management of memory, we should know what is the data type size. So, we will see the data types, primary data types, integer, floating point, double, and char. So, what is the definition? Integer means number without decimal value. So, you are declaring int a is equal to 6. So, a has the value 6. Now, floating point is a number with a decimal value. That is float y is equal to 6.5. Number now here double peri 50,000. That means perimeter. Perimeter is equal to 50,000. Now character, it is any symbol, number, alphabet which is enclosed in single quotation. That is, example, I want to declare a batch. That is, the student belongs to batch A. So I will declare it as char batch is equal to within single quote A. Now, how do we represent it? Integer is represented using the keyword int, floating point using float, double using double, and char using char. Memory size, short int is 2 bytes, long int is 4 bytes. Floating point 4 bytes, double is 8 and 10 bytes, character is 1 byte. Now range, signed short int. Signed short int is in the range 32,768 to 32,767. Unsigned is 0 to 65,525. Now, coming to floating point, it is 1.2 E to minus 38 to 3.4 E plus 38. That is 6 decimal places. Whereas double, first it will 8 bytes, it will carry 15 decimal places, and long it will carry 19 decimal places. Now, coming to the character, it is minus 128 to 127. Now, type specifier. The type specifier is %d or %i or %u. Some of this application we have seen an examples in the previous episode. Floating point is %f. This is %ld. This is %c or %s. If it is a single character, we'll use %t. If you are using a string, that is an array of characters, we use %s. Now, coming to the question number 23. What are the various keywords? Every language has a set of keywords. What is a keyword? We have seen it has a reserved meaning. We have to use it only for that particular purpose. You cannot use it as a variable name. I can't use these words as any variable names. So we have auto, break, case, char, const, continue, default, do, double, else, enum, extern, float, for, go to, if, int, long, register, return, short, sign, size of, static, struct, switch, type def, union, unsigned, void, volatile, while. Of these, the most important which we will commonly use are auto, break, case, char, const, continue, do, double, else, enum, float, for, go to, if, int, long, return, short, signed, size of, static, struct, switch, type def, union, unsigned, void, and while. These are the most important keywords we will be frequently using. Now, coming to the question number 24. How are variables and constants represented? Constant. Constant is a variable which remains the same throughout the program's execution. There can be any type of constant like integer, float, octal, hexadecimal, character, constants, etc. So how do we specify the constant? Example, const, float, pi is equal to 3.14. In mathematics, pi is equal to 3.14. So constant are declared using the const keyword, followed by the data type of the variable or value and the variable name. Character constants are single characters enclosed in single quotation marks, such as this single quotation mark. Example, const data type variable name. Const int minimum is equal to 30. That is, I want to set the minimum marks in a class to 30. I can use it as a constant. Then const char division is equal to A. I want to specify this division as A. Then I'll give it in single quotes. Coming to a variable is a value that can change during program execution. It represents an unknown value. In a program, we want to add two numbers, but the numbers will be entered as and when required during execution, because each time I will want to add two different numbers. So I will keep it as a variable. The syntax is data type variable name. That is int x, or if it's a char b. Now we'll just see a small example using this data constant variables. This is a program to print circumference and area of a circle. So this is a comment statement. So main, opening the main program, open the main. So I am declaring const float pi is equal to 3.14 value. Int r. R is the, since I want to calculate the circumference is equal to 2 pi r. Area is pi r square. So I need the variable for the radius as int r. Now I need a variable to store the value of the area and the circumference. So I'll declare another variable area and another variable CIR for circumference. Accept value of the radius. Now I have to accept the value of the radius because area and circumference are dependent on radius. So printf, enter the value of the radius in centimeters. Scanf %d ampersand r. I have accepted the value of r. Now I am going to compute the area and circumference. So area is equal to pi r square. So pi into r into r. Circumference is equal to 2 pi r. So 2 pi r. Pi already we have given 3.14. So I need not give here 3.14. Now I'll display the result. Printf, area of the circle is equal to %2f/n. This 2f means 2 decimal places. Since this I have declared as floating, I will want only 2 decimal places to be displayed. So I'll say 0.2f/n. Then area. So I want the area to be printed. Now I have given a semicolon here. That means this statement is terminated here, and this printf will come in the next line. In the next line, I will display circumference the circle %.2f/n. So depending upon the value of r you get, the area and the circumference will be displayed. Now, question number 25. How are executable statements and non-executable statements, that is comment statements, identified? Now, C statements, there are two types, executable, non-executable. Now, statements that indicate action to be taken by the CPU are executable statements. Statements that provide information about the program but do not indicate any action to be taken by the CPU Now here we have this comment statement, which is non-executable statement. All these 4 lines are executable. Again, this is non-executable, executable, executable, non-executable, then executable, executable, non-executable, executable, 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 executable. So like this, we can categorize into executable and non-executable. Non-executable, giving comment statement is good so that we know what we are doing in the program. Now, executable statements are converted to machine code, but non-executable statements are not converted to machine code. Now, example of executable statements are arithmetic statements, branching, looping statement, and decision-making statements. Non-executable comment statements, which we have seen in the previous example. Now, coming to question number 26. Is the language free-form and case-sensitive? Yes, C is case-sensitive. All commands in C must be lowercase. C has a free-form line structure. That is, each end of each statement must be terminated by a semicolon, but they can be typed anywhere in the editor. So, suppose this is, we know that this is the editor. So, I explained in the previous episode that normally we start from the top row, left side. That is the first row, first column. So, here we have main, open the flower bracket, opening the main function, printf hello, and closing the main function. So here every statement is terminated with a semicolon. Here we have seen that it is all written in small letters, but it is free form. That is, this flower bracket, I can even put it beside the printf statements, but the order is important. It should come before the printf. Now, question number 27. How are statements terminated? Each statement in C is terminated by a semicolon. This is a very important question. In most of the interviews and competitive exams, they will be asking this question. Now, coming to 28. How are the global and local constants identified? Global constants are declared outside a function. They are defined with the directive #define. Now, suppose you are having 2-3 files related to a particular aspect. Say you have a class of students and you are processing 2-3 different types of information of the class. That is, one is the ranking, then comparing with other batches also. Then you will be writing 2-3 different programs. But in the 3 programs, you want the minimum marks to be the same. So you can keep that constant as a global constant. So #define minimum marks as 40. Local constants are declared inside a function, and they are declared using the const keyword. Const float pi 3.14, which we have used in our previous program. So here I will show an example where we are using both global and local variables. So program using global and local constants to calculate the angular frequency omega 2 pi f. That is, we have a motor which is rotating and we want the angular frequency. So then the angular frequency omega is given by the formula 2 pi f. So I will include #include stdio.h. As I've said, you need to have the header files. Then #define pi 3.14. This is the constant. This is a global constant. Main, this is local constant. Constant f is equal to 50. Frequency I'm taking as 50. So I'm declaring it as a constant as 50. So this is a frequency f is 50 Hertz, local constant. So float omega. Omega is equal to 2 pi f. So here I have pi and the frequency f. So printf angular frequency is equal to 2 percentage 0.2 f omega. That is, I want 2 decimal places. So if the answer is angular frequency is equal to 314.00, because here I have given 0.2 f. That's why I will get 2 decimal places. So in this way, you should plan your local and global variables. Now, what is the operator precedent? Question number 29. The following table lists the order of precedence of operators in C. Every language has its own operator precedent, but most of them have to consider the mathematical precedence. Operators with the highest precedence appear at the top of the table and those with the lowest appear at the bottom. That is what I've said as serial number 1. They have high precedence, and what as we are going down, you have lower precedence. And the order of evaluating an expression also is given in this column. So we have the category postfix. You have the various brackets, then direction, dot, plus plus, minus minus, and this is evaluated left to right. Now what are all these? We will see subsequently in our examples. Now unary operators, plus, minus, not equal to, you can say, then tilde or exclamation marks. This is exclamation mark, tilde, plus plus, addition, minus minus, type, asterisk, ampersand, size of. This is evaluated. They are evaluated left to right. Similarly, multiplicative. Multiplication, division, modulo. Modulo, this percentage sign is used for modulo. Left to right. Additive, plus minus, left to right. Shift, double shift, left side, double shift, right side, left to right. Relational, less than or equal to, greater than equal to. They are evaluated left to right. So how to use them, we will see in our examples, as we are taking up many examples in another episode. Now we have some more. We have some more operators, categories of operators, which is continuation here. That is bitwise and, bitwise XOR, bitwise or, logical and, logical or, conditional operator. This is equivalent to if-else statement, which we will be using frequently. Assignment operators, and you have comma, evaluated left to right. So within an expression, higher precedence operator will be evaluated first and lower precedence operators will be evaluated last. Now, coming to what are the various built-in library functions? How are they invoked in the program? In the previous episodes, I have explained that C is very strong language because it has a number of built-in functions. That is, functions which we commonly used, the program for them are already written and kept. So we only have to invoke that function and use that particular program. So the built-in functions, also called as library functions in C, are invoked using the #include directive. The various libraries and the functions included in each library are the library functions in C. They are included in standard header file functions. Like I have explained to you the various types of header files in my previous episode also. So here in C we have stdio.h, a standard library stdlib.h, console input output conio.h, C type character, the C stands for character type.h, mat.h, string.h, process.h. So in the stdio.h, we have for input, we have printf function, scanf function, getC function, putC function, getString function, putS function. So these, depending upon a data type, we have to use these functions. Now, what are the standard library general utility function? A to F, A to I integer, A to L, A to LL, random, exit, abort. Mostly in this we may use random and exit, but the others are not really much used by us unless you are going for high-end programming. Now, console input output H, you have for console input output CIR, SCR, clear screen, CLR, SCR, that is clear the screen, get char, get ch, and get che. The character handling, is alpha, is digit, is lower, is upper, to lower, to upper. These also will be using much. Now say you are entering an application form and they say it should be specific whether you are entering in uppercase or lowercase. So while evaluating, they want to check whether it is lower or upper. Then they will use this function, is lower or is upper. Or you want to convert, if they have written in upper or lower, you want to convert all of them to lower, you can use this to lower to upper. So this for character handling, we use this header file. So you have to say hash include ctype.h. Now mathematical functions, we have square root, sqrt, power, pow, ceil, minimum value, floor, f, absolute value, sine, cos, tan. These are the trigonometric functions. So mathematical operations, we will be using these. Now coming to string functions. String handling functions are strlen. You want to find out the length of the string. strlwr, write the string. strupr, upper. strrev, you want to reverse a string. strcpy, copy. strcat, you want to concatenate. CAT is for concatenate. You want to join two strings. strcmp, compare two strings. Like you have two words, you want to compare the two words, whether they are same or no, you use this strd, upper. Then process.h, process and thread. This is also again for very high advanced programming. Get PID, begin thread, end thread, cexit, execcil, execv, spawnl, spawnr. Right? These are the most common compulsory for library functions. We have to use it stio.h, and then depending upon if you are using character type, you can use this ctype.h. If you are using mathematical operations, mat.h, and if you are using string operations, you use string.h. So these are the 5 library functions which will be most commonly using. Now, here I have presented the programming design and development as an operation research approach. That is how you should write a program. You may know and you are learning all the concepts, but you should have a systematic method of writing a program. So the steps are, first you read, study and clearly understand the problem statement. So what is the problem? For what they want you to write the program? Say in the previous example I have given, write a program to find the area and circumference of a circle. So first you should read the question and understand what they are asking. So then identify the variables and the constant. So in our program of area and circumference of a circle, we have identified what are the variables. What is the variable? Area and circumference, because they will change with the radius. The constant is pi. So we have identified the constant pi. So first you identify the variables and the constants in that particular program statement. Identify the dependent and independent variables. What are the dependent and independent variables? If you have little exposure to OR, you would understand this more clearly. Okay, no issue. Now, what are the dependent and independent variables in our program? What are the dependent variables? Area and circle. Area and circle are dependent variables. On what they are dependent? They are dependent on the radius. So, radius is an independent variable. Now, identify suitable names of all variables and constants. Now, giving the appropriate and correct name to your variables and constants is very important. Say pi I have given for pi. Immediately I know it is pi. F I have given for frequency. Omega I have given for omega, that is angular frequency. Or as here I have given for area, AREA and CAR. So once I know CIR, I know it is circumference. AREA stands for area. So in this way, you should give appropriate names for your variables and constants. So immediately you will understand what it is storing. Now, if it is a technical problem, this is the various equations. Now, in the previous example, we have written area is equal to pi r square and circumference is equal to 2 pi r. So, in this way, you should write down the equations. Even if you are in economics, you are doing something related to economics, also you can write down the appropriate equations. Then, step 6, decide on how to accept the input variables and display the result. That is what data type you will select, int, float, char, string, and how you will display the message. That you have to first plan so that you will be able to write your print and scanf statements correctly. Now, step 7, decide on the logic construct to use. That is what logic construct you will use: loop, if else, do while, arrays, switch statement, subfunctions, pointers, etc. So which of these you will be using for your particular program, better we prepare and keep. You can also write an algorithm and keep. Now, then you start writing the code. Now, having planned all these things, you can start writing the code. Now, initially only write the starting directive, that is pertaining statements as main function in C, right? Then write the data declaration and input statements. Debug and compile. So once you written the data declaration input statements, you debug and compile to see if there are any errors. Then eliminate those errors, and then you again start writing the logic constructs and relevant output statements. Again debug and compile and see if there are any errors. So keep on repeating this process, like add every few lines of code, and then you keep repeating the process of debugging, compiling, and then once you have corrected all the errors and you have completed writing the entire code and found that it is totally error-free, you can run the program, identify if any runtime errors are there, and debug. So these steps 8 to 9 are repeated until the final error-free code is developed to meet the problem statement. Now here, that is here in this particular example, I will show. First, you are writing the main, declaring the variables, and then you accept the radius. Once you accept the radius, you can write here, add one more print statement and print the radius to check whether you are accepting the radius correctly or no. Once you know you are accepting the radius correctly or no, then you compute area and circle, and then you print these, and finally debug and compile. You see whether it is totally error-free and see it is executing correctly. So in this way, you can develop the code, not the entire code at a time, but in stages. So it will enable you to develop fast, and also enable to you rectify any errors very easily. Now here I am just giving a small program, one more program, to find the hypotenuse of a right angle triangle given base and height. That is, I am including, because base and height, I am half base into height. Hypotenuse is square root of, you are getting square root of base square into height square. So here I am giving the declaring the variables. So stdio.h, mat.h also I am including because I am using sqrt. Then declaring the variables for base and height and hypotenuse of a right angle triangle. So float, base, height, hypotenuse. Printf, enter the base of the triangle in meters. So here I am specifying you should enter the base in meters only. So scanf %f ampersand base. Printf, enter the height of the triangle in meters. Again, scanf %h ampersand height. Then I calculate the the hypotenuse, square root of base square into height square. So I print the hypotenuse as percentage of meters, you will get the hypotenuse. So here execution of output, enter the base, I am entering 10, enter the height, I am entering 5, you calculate the hypotenuse 11.88. In fact, we should get more decimal places. Sorry, I missed here, 11.8. So 11.18000 we have to print because I have taken float here. So what float has? What does float contain? See, float, it decimals 6 decimal places. So because it is saying 6 decimal places, what should have been my output here? Because I didn't give 0.2f or anything here, I'm just saying percentage f. 180000 should have been the output here. Now here I've given just some important questions relating to your interview and quantitative exams. Now, the C preprocessor directives are specified with dash symbol. You may study this episode and then fill up this blank. Scanf is a predefined function, is dash header file. Which header file scanf is mentioned? What will the final value x in the following C code? So after executing, you use the operator precedence, which you have seen the table. Using that operator precedent as in mathematics, you evaluate and give the value